Friends, now we have to learn how to solve linear equations. 2x plus 3y is equal to 2 and x minus y upon 2 is equal to 1 upon 2 by Cramer's rule. We have to solve these linear equations by Cramer's rule. Friends, don't forget to subscribe our channel so that you will get our new coming videos. 2x plus 3y is equal to 2 and x minus y upon 2 is equal to 1 upon 2. These are two given linear equations. Now to solve these equations by Cramer's rule, first we have to change these equations in their simple form. Ax plus by is equal to c. That means we want term of x as a first term plus term of y as a second term and is equal to, in the right hand side we want constant term. According to it, our first equation remains as it is, 2x plus 3y is equal to 2, and in our second equation we have to remove denominator, and that's why we have to multiply each term by 2 so that we will get simple equation. 2x minus y is equal to 1, which is also in the form ax plus by is equal to c. Now to solve these two equations by Cramer's rule, first we have to find determinant d. Determinant d has two columns. First column is the coefficients of x from these two equations and second column is the coefficients of y from these two equations. So D has 4 elements in 2 rows and 2 columns. In first column coefficient of x 2 and 2, and in second column coefficients of y 3 and minus 1. So its value is equal to, in first term we have to write product of elements in principal diagonal. So 2 into minus 1 minus, for subtraction we have to use sign minus. Now in second term we have to write product of elements in secondary diagonal. So it is 3 into 2, which is equal to, solving these products we get 2 into minus 1, that is minus 2, minus 3 into 2, that is 6, is equal to minus 2 minus 6, that is minus 8. So this is the value of determinant d, minus 8. Now we have to find determinant dx. Same as above determinant d, only we have to replace first column, means coefficient of x, by constant terms. We have to replace first column coefficient of x by constant term. So determinant become, in first column 2 and 1 as a constant terms at the place of coefficient of x, and second column as it is coefficient of y 3 and minus 1. So it is equal to, now we have to find its value. First term is product of elements in principal diagonal 2 into minus 1 minus, for subtraction, and second term product of the elements in secondary diagonal 3 into 1, which is equal to, solving the products we get 2 into minus 1, that is minus 2, minus 3 into 1, that is 3, which is equal to, doing subtraction we get minus 2 minus 3, that is minus 5. Now we have to find determinant dy. Here in this case we have to replace coefficients of y instead of coefficients of x by constant terms. That means first column remains as it is as a coefficients of x, and in second column we have to put values of constant terms. So the determinant is, in first column 2 and 2 as the coefficients of x in two equations, and in second column instead of coefficient of y we have to write constant terms 2 and 1. Its value is equal to, in first term product of the elements in primary or principal diagonal 2 into 1 minus for subtraction, in second term product of the elements in secondary diagonal 2 into 2, which is equal to, solving these products we get 2 ones are 2 minus 2 twos are 4, so which is equal to, solving this subtraction we get 2 minus 4, that is minus 2. So this is the value of dy. Now using all these three determinants d, dx and dy, we have to find values of variables x and y. So value of variable x is equal to its formula dx upon d. So is equal to value of dx minus 5 upon value of d minus 8, which is equal to, minus minus become plus, so the answer is 5 upon 8. So this is the value of variable x, 5 upon 8. And value of variable y is equal to its formula dy upon d, which is equal to value of dy minus 2 upon value of d minus 8. So is equal to, solving this we get 1 upon 4. So 1 upon 4 is the value of variable y. So in this way, by Cramer's rule, we can solve any general linear equations. Here value of x is 5 upon 8 and value of y is 1 upon 4.